Okay, so now we are at the side page 338. Okay, and we are going to talk about voltage for RL. Okay, voltage for RL. Okay, so the first diagram here is about the resistor. Okay, so here is about resistor. What we are going to do? We have a AC, and we have a resistor and an inductor. Okay, and we put a ammeter here to measure the current. Okay, and we put a voltmeter here to measure the voltage across the inductor, like we did for capacitor. Okay, and you need to know, I think you should remember, okay, for the inductor, okay, they are the induced voltage from the inductor, they are proportional to the rate of the changing current, which will be in this way. Okay, and if we put that into the diagram, so this is time, changing time. Okay, and here is current. Okay, changing current, and then this one become the gradient. Am I right? The gradient, G-I-D-I-E-N-T, the gradient for this graph. Okay, now this is the voltage from the power supply, which is no surprise. Okay, and apply V equals to IR, and I equals to V over R. Okay, so the current is in phase with the power supply from the supply across the current, and that will same with the inductor. Okay, and now we want to talk about the gradient. Okay, the gradient. So if you check the gradient of the current, the gradient here is actually 0. Okay, and they start to increase, and here is the maxima of the gradient, and then they drop to 0, decrease, increasing here, decreasing here, becomes 0. Okay, so in this point delta T delta I is 0. Okay, and that also means if this is the value of the inductor will be 0. Okay, and here will be 0 again for VL. Okay, because the gradient here is 0. Okay, and then for here is the maxima gradient. Okay, maxima gradient. Okay, so VL will be somewhere maxima. Okay, and then they are going to decrease in a negative gradient in this area, so little gradient here will be VL, will be here. So if we draw a diagram, okay, this will be our diagram. That makes sense to you? Okay, I hope this makes sense to you. Okay, so this is the main idea, and now we have some revision. Okay, we read the text for revision. Okay, so this is the induced current from the inductor. Okay, so now we need to draw this one carefully. So when I equals to 0, okay, when I equals to 0 is actually this point. Okay, when I equals to 0 is this, oh sorry, when I equals to 0, yes, okay, when I equals to 0 is this point. Okay, and the rate of the changing current is maxima. Okay, so that means the VL is maxima. Okay, VL is maxima. Okay, and then I change the color. Okay, so the rate of current is 0 when I is maxima. Okay, when I is maxima. So when I is maxima and VL is 0. Okay, that's what it means. Okay, so that as a consequence, the voltage across the inductor is a maxima when I equals to 0. Okay, I change to yellow when I is 0 and the inductor voltage is maxima. Okay, exactly same with this one. Okay, so now based on this understanding, we put this one to our diagram. Okay, I think the order here is fine, but the best way to read is probably read this one first. Okay, so what does that mean? Okay, so let's have a look. Okay, so when VR equals to 0, and what does that mean? when VR equals to 0, VR equals to 0, if you check the diagram, VR is here. When VR is 0, VR is 0. Okay, okay. When VR is 0, okay, and the changing or the gradient is maxima. Am I right? Okay. And if this is maxima, so what? So VL will be maxima. Okay. So if VR is 0 and VL is maxima. Okay. And he write, this is because the rate of the change current is the, I probably use green. The rate of the changing I is maxima. Okay. And when this is VR equal, this is very bad one. Okay, this is confusing. It actually means I or VR is 0. Okay, so if you read this one, then you know. Okay, when VR is 0 here, VR is 0 here, and our VL is maxima. Okay, and then because this one in terms of gradient, this is a gradient maxima and it's decreasing to 0. Okay, so our VL is decreasing, and when VR is maxima, now we go to the second one. When VR is maxima, okay, when VR is maxima, so you read the second one. VR here is maxima, okay, and VL drop to 0. Okay, so it's here. So this is second point. Okay, and then VL reach maxima before. So I think this one and this one, they just want to tell you it is opposite to ICE. If you remember ICE, for capacitor current lead. Now we are in inductor. So this is capacitor. Okay, and now we are in inductor. Inductor L. Okay, and we have a name we call AD. Okay, it's a, I don't know, ELI, AD. Okay, so for what? For inductor. Okay, the voltage lead, VOLTAGE, voltage leaders. Okay, and this is current leaders. I probably want to move this one away. Okay, yeah, okay, hope this makes sense. Okay, so these are the two main difference between capacitor and inductor. Okay, so for conductor, for capacitor, the current leads. Okay, and for the inductor, okay, for the inductor, the voltage leads. Okay, yeah, hope this makes sense.